Assalamu alaikum. My name is Wazula Tanzim and this presentation is submitted to our honorable teacher Syed Muhammad bin Haj Hossain sir. Today is 1st May 2021. Let's start our presentation. Today's topic is multiplicative inverse. Find multiplicative inverse of 17 in Z subscript of 35. Answer. So first of all, we have to assume that t1 is equal to 0 and t2 is equal to 1. Then we will apply an equation in this problem, that is t is equal to t1 minus t2 into q. In this topic multiplicative inverse, we need q, r1, r2, r, t1, t2 and t. Q is equal to quotient and r1 is equal to divisible and r2 is equal to divisor, r is equal to remainder. So here t1 is equal to 0 and t2 is equal to 1. Okay, so now r1 is equal to 35 because 35 is greater and 17 is smaller. Now 35 is divided by 17 is equal to quotient is equal to 2 and remainder will be 1. Okay, now t is equal to, we know that t1 minus t2 into q. Here t1 is equal to 0, so 0 minus 1 into q is equal to minus 2. In the next row, r2 will be shifted at r1, r will be shifted at r2, and then t2 will be shifted at t1, t will be shifted at t2. Then we will divide 17 by 1, so quotient will be 17 and remainder will be 0. Here we will find the value of t using this equation. Okay, so here t1 is equal to 1 minus t2 is equal to minus 2 into q, so minus 2 into 17 is equal to minus 34. So 1 minus minus 34 is equal to 1 plus 34 is equal to 35. Okay, so in our final row, this is our final row, we can see that we will shift r2 at r1 and r will be shifted at r2. In this line, t2 will be shifted at t1, t will be shifted at t2. So now we cannot divide 1 by 0. Okay, for this reason quotient will be cross, remainder will be cross, so t will also be cross. So from this final line we will decide that the value of r1, which is 1, will be our GCD, and the final value of t1 will be our multiplicative inverse value is equal to minus 2. Next, here we find out that GCD is equal to 1 and multiplicative inverse is equal to minus 2. Multiplicative inverse is in negative form. We can see that multiplicative inverse in negative form. We can find multiplicative inverse in positive form, such as multiplicative inverse is equal to 35 plus minus 2 is equal to 33, which is in positive form. Moreover, we can check this answer in modular inverse form also. So we find out multiplicative inverse in negative form minus 2 and positive form 33. We can also find out this result using modular inverse method. Both methods answer are same but to different rule. Here a is equal to 17, m is equal to 35. We can see that a and m are relatively prime because we can divide them only both of them by 1. So for the negative form of multiplicative inverse, which is minus 2, 17 into minus 2 mod 35, we get the answer 1. So minus 2 is the modular inverse of 17. Minus 2 is the modular inverse of 17 under 35. Again, for the positive form of multiplicative inverse, 17 into 33 mod 35 is equal to 1. So here 33 also modular inverse of 17 under 35. Extended Euclidean algorithm. Now we will discuss about extended Euclidean algorithm. Find the GCD of 179, 21. Answer. So here this is an equation. A into S plus B into T is equal to GCD A comma B. Okay. This equation will be fulfilled if we correctly find out the value of S and T and GCD A comma B. That's called linear equation. This equation is known as linear equation. If we find out the correct GCD and S and T, this equation will be fulfilled. Okay. Now we have to assume that S1 will be 1, S2 will be 0, T1 will be 0, T2 will be 1. In extended Euclidean algorithm, we have to use two equations. One is S is equal to S1 minus S2 into Q, and next is T is equal to T1 minus T2 into Q. So in the first column, Q1 is quotient, R1 is the divisible, and R2 is divisor, R is remainder, and here S1 S2, here S1 is equal to 1, S2 is equal to 0, and we will find the value of S using the first equation. Then T1 is equal to 0, T2 is equal to 1. Okay, we assume that. Okay, then we will find the value of T using the second equation. Here T is equal to T1 minus T2 into Q. Now 179, if we divide 179 by 21, 179 divided by 21, we will get quotient 8 and the remainder will be 11. We can find out the value of S using this equation, this first equation. Here S1 is equal to 1, so 1 minus S2 is equal to 0, so 1 minus 0 is equal to 1. Now we have to find the value of T. T is equal to T1, the 0 minus T2, 1 into 8 is equal to minus 8. In the next row, we will shift the value of R2 at R1, R at R2, then the value of S2 will be shifted at S1, and S will be shifted at S2, and T will be shifted at T1, T will be shifted at T2. Then if we divide 21 by 11, quotient will be 1 and the remainder will be 10. Then here S1 will be 0, S2 will be 1. So we have to find out the value of S using this equation. Okay. Next, similarly, we have to find out the value of T using this equation. So the value of S is equal to minus 1. Okay. Here S1 is equal to 0. 0 minus 1 into 1 is equal to minus 1. In the value of T is equal to 9. Okay. So 1 minus 8 into 1 is equal to 1 plus 8 is equal to 9. In the next row, the value of R2 will be shifted at R1, the value of R will be shifted at R2, and the value of S2 will be situated as 1 and the value of S will be situated as 2. The value of T2 will be situated T1, the value of T will be situated T2. Then if we divide 11 by 10, we will get quotient 1 and remainder will be 1. And the value of S, 1 minus 1 into 1 is equal to 2. Now the value of T1 is equal to minus 8. So minus 8 minus 9 into 1 is equal to 17. In the next row, R2, the value of R2 will be situated R1, the value of R will be situated R2. Okay, then the value of S2 will be situated S1, the value of S will be situated S2. Then the value of T2 will be situated T1, the value of T will be situated minus 17. Now in this section, if we divide 10 by 1, if we divide 10 by 1, we will get quotient 10 and the remainder will be 0. Then we will again find the value of S using this equation. Okay, minus 1 minus 2 into 10 is equal to 21. Okay, then 9 minus 17 into 10 is equal to 179. So in the final line, we will again shift the value of R2 at R1, the value of R at R2, and then S2 will be stated as 1, the value of S will be stated as 2, the value of T2 will be stated T1, the value of T will be stated T2. Okay, we know that we cannot divide 1 by 0, so quotient will be cross, remainder will be cross. So S will be cross, T will be cross. So here R1 will be our the final value of R1 will be our GCD, and we will update the value of S is equal to S1 is equal to 2, and then we will again update the value of T is equal to T1 is equal to minus 17. So the final value of S1 is equal to, which is, we update the value as S is equal to 2, then T, we find the value of T1 is equal to minus 17, we update the value of T is equal to minus 17. Okay, here S is equal to 2, T is equal to minus 17, and GCD is equal to 179, 21 is equal to 1. Okay, now we can prove extended Euclidean algorithm by linear equation. Okay, so A into S plus B into T, here the value of S is equal to T is equal to minus 17, the value of GCD A comma B is equal to 1. So left hand side is equal to 179 into 2 plus 21 into minus 17, we get 358 minus 357, which is equal to 1. The value of 1 is equal to GCD 179, 21. So which proves that left hand side is equal to right hand side. So from this we know that extended Euclidean algorithm follows the linear equation. Thanks for watching. Goodbye and take care.